Our goal is to solve this logarithmic equation. I'm going to start on the left-hand side, and notice I have two separate logarithms. The bases are the same, and that's good news, and they're subtracted. So I'm going to use the property of logarithms that says when I have two logarithms that are subtracted, I can rewrite them as a single log, same base, with the two expressions divided. So I'm going to do x plus 2 divided by x minus 1. There's my new improved left-hand side. On the right I have equals 1. Nothing to do over there. Well, now I have a logarithm equals a constant. The next part of my goal here, I'm going to rewrite this in exponential form. We can rewrite any logarithmic expression in exponential form. I'm going to start with the base. This is log base 4. There's my base. So 4 is my base. To the, well, a logarithm is an exponent. My exponent is what's over here on the other side. So 4 to the first power. No, you don't actually have to write that because we know that's just going to end up being 4, but I'm going to do it at least for this one. Equals that expression. So that's x plus 2 divided by x minus 1. Well, look what we have now. It's not a logarithmic equation anymore because the logs are all gone. Now it's a rational equation. So we're going to solve this in the usual way for rational equations, which is to say I'm going to multiply both sides of my equation by my common denominator. Well, there's only one denominator, so hopefully that's not too strenuous to figure out. 4 to the first power, that's just 4, and I'm going to multiply by the denominator x minus 1 equals, when I multiply the right-hand side here by the common denominator x minus 1, it's going to divide away with the denominator, and I'm left with just what's in the numerator, which is x plus 2. Even better news, now that's a linear equation. I'm going to distribute on the right. 4x minus 4 equals, nothing to do on the left, still x plus 2. Next, I'm going to combine like terms, so 4x minus x, and I'll add 4 both sides. Looks like I'm going to have 3x on the left equals 4 plus 2, 6 on the right, which means if I divide by 3, I get x equals 2. As with any logarithmic equation, we can't rest on our laurels just yet. We have to check for extraneous solutions because the domain of the logarithmic function is positive values only. Even though the x value I got was positive, that doesn't mean that it's automatically going to work. So I'm going to go back to the original equation up here before I did any changes at all to it. And I'm going to replace all the x's with the value I got, which is 2. So I have log base 4 of 2 plus 2. Well, I can do that one. 2 plus 2 is 4. That's positive. So far, so good. Let's keep going. Minus log base 4 of x minus 1. Well, 2 minus 1, that's positive 1. Hey, looking good. Equals 1. If we think through this, I have log base 4 of 4. That's 1. Log base 4 of 1, well, log base anything of 1 is 0. So this says 1 minus 0 equals 1, which it does. Which means our solution is x equals 2.